Matrices and systems of linear equations, part 2. All right, this is example 4. All right, it says a bead store has a sale on certain beads. Find the price of each size of bead. All right, so that's the question. Find the price of each size of bead. All right, so we have 2 large beads and 3 small beads cost $3.25. 3 large beads and 4 small beads cost $4.75. All right, so if we let X be the price of 1 large bead and Y be the price of 1 small bead, then we can write this as a system of equations. So let's say 2 times large would be 2X plus 3 times the small is 3Y. And that's going to equal $3.25. All right, the second one says 3 large beads, so 3 times X's large beads again, remember, and 4 small beads is Y, and that's going to equal $4.75. All right, now so we can do a couple things with this. We could write it in an augmented matrix if we wanted to. We also could write it in separate matrices, which is what I like to do. So I'm going to write it as 2, 3, 3, 4, and then XY, and then put my constants, 325 and 475. This just kind of sets it up as matrix A and matrix B, so we can do A inverse times B. All right, so if we do that, let's go ahead and look at multiplying or solving this matrix equation using our calculator. All right, let's put in matrix A and B. So we've got matrix A. So let's go to edit. And we have a 2 by 2 matrix. So we need to edit. And we're going to say 2 by 2. And now we're going to replace the numbers in there with 2, 3, 3, 4. So 2, 3, 3, 4. And then second quit. That saves the matrix. Let's do second matrix again. This time we're going to edit matrix B. Then it is a 2 by 1. 2 rows, 1 column. All right, so we've got $3.25. And we've got $4.75. And we're going to hit second quit. We're going to save that matrix. Now we're going to do A inverse B. Every time is going to be A inverse B. This is how you solve a matrix equation using your calculator. All right, A inverse B, 125 and 25. So X equals $1.25. Y equals 25 cents. So what does this mean? It says find the price of each size of bead. So X is the price of a large bead. So 1 large bead cost $1.25. 1 small bead cost 25 cents. Example 5, modeling real life. You have $10,000 to invest in a stock fund and a bond fund. You target an annual return of 6.5% based on current returns since interception. How much should you invest in each fund? All right, so we are given a table here that says average annual returns. And so that means yearly returns. And then this is based on 1 year, 3, 5, 10, and since interception. So right here it says based on current returns since interception. So we are going to be looking at this part of the graph or using that part of the graph. And we can see that stock is yellow and bond is red. So just kind of get familiar with the information you're given before you try to dig in and see what you need to do. All right, so it says how much should we invest in each? All right, so let's look again. You have $10,000 to invest in stock and bonds. Okay, so $10,000 to invest in stock and bonds. So let's say let X be the amount invested in stock and Y be the amount invested in bond funds. All right, that kind of gives us variables to define. So if we have $10,000 to invest in both together, we can say that X plus Y is going to be $10,000. So that's one equation that we have. Now it says your target, you target an annual return. So that means a yearly return. Again, this is our table on average annual returns. So you target an annual return of 6.5% based on the current returns since interception. So again, the since interception, that is on the graph, and it says at since interception, stock returns have been at 9.5%. So again, stock is our X value. So we can take 9.5% and write that as a decimal. So let's write that as a decimal. Remember, to write it as a decimal, you got to move it 2 decimal places. So it's going to be 0.095. And again, X represents stock. And then plus the 4.5%, we have to again write that as a decimal, but that is what represents our bond fund. So 4.5 will be 0.045. And that represents the bond. All right, now we have an equation, and since we turned the percents into decimals, we moved it 2 decimal places. So we also will have to move this 2 decimal places as well. So 6.5 is going to be 650. All right. Now, we have 2 equations, so we can quickly set this up into a matrix equation. So we're going to have 0.095, 0.045. All right, we have X and Y, and we're going to have 10,000, 650, and then I'm going to plug that in my calculator. All right, so I'm going to pause the video just a second so I can plug these matrices in, and then we will see if we can solve for X and Y. All right, so I have entered this matrix as matrix A, and I've entered this matrix as matrix B. Now we can do A inverse B. A inverse times matrix B. And that says 4,000 and 6,000. So we've got 4,000 and 6,000. Remember that X is the amount invested in stock. So we want to put $4,000 in stock. And we want to put $6,000 in bonds. So how much should you invest in each fund? According to this system of equations, your best option would be to put $4,000 in stock and $6,000 in bond. All right, that is all for matrices and systems of equations. If you have any questions, please let me know.